Joe is the founder and CEO of EcoLayers Inc. and he brings over 35 years of experience in commercializing innovative technology solutions for complex problems in infrastructure industries such as electric power, telecommunications, software and solar. Joe began his career at General Electric, where his team invented, designed and demonstrated the first microprocessor-based real-time distribution, automation and protection system for electric utilities. At AT&T, Joe worked in market development to commercialize wireless voice and video technologies which have evolved into a modern internet. He then joined Amoco's technology division to grow their photovoltaic business in large-scale utility applications. Joe received his undergraduate and graduate degrees in electrical power engineering from the Indian Institute of Technology, India, and the how do you pronounce that one, Joe? Rensselaer Polytechnic Institute in okay, and an MBA in Finance and Marketing from the Wharton School of Business. Okay, so Joe, I'm going to hand over the presentation software to yourself.
Okay.
And just for anybody who is on the line, there's a lot of people on the line at the moment, so I've muted everybody. If you have a question for Joe at any point, if you could please send it to the webinar software or send it to myself. And if we need to stop Joe and ask for a clarification, well, we will do, but otherwise we'll hold a Q&A session at the end. Okay, so Joe, if you want to make that full screen and you'll be ready to go.
Okay. All right.
Perfect.
First, let me thank you, everybody who's participating, for taking time out of your busy schedules, and I'll do my very best to make it absolutely worthwhile for all of you. Before getting to the core of the presentation, I would like to make a general comment, an overarching comment, regarding the topic for the webinar. You might have heard about the general concepts of what an environmental asset is. There's a lot of stuff that's been written up, a lot of research that's been done. But when it comes to the management of it, and by that I specifically mean the systemic, integrated, and collaborative management, including planning, inventorying, maintenance, etc., and the tools to accomplish that, there's hardly anything out there that I have come across in the many years that we have been doing this. So there is a kind of a little bit of an innovation here, and because of that, I'm sure we'll come across some concepts that, at least, again, I do not claim to be the vegetation management expert. I'm not a utility arborist or a utility forester, but there might be some concept that might be different from what you might be familiar with in the typical vegetation management presentation. However, let me assure you that everything that we talk about is real. This is not theoretical stuff. We are actually implemented systems. And I would suggest to kind of look at this discussion as, on the conceptual side, that, sometimes like 90% of the solution depends on how you define the problem. So I think fundamentally what we have done is kind of redefine the problem a little bit. And as far as the implementation is concerned, the tools and technologies, everything is all there. So there's no kind of rocket science or anything theoretical stuff involved. So with that background, let's go over the lay of the land, what we're going to talk about today. The introductions are done. I think it's nice to kind of introduce the topic of what an environmental asset is, why it is different. I will make the claim that it is very different from built assets, but in what mechanisms? And that has an implication on how you want to manage them, which of course is the business implications. That's what we'll get into next. And then to make it real, how do you actually go about it? Whether you're today using manual systems or you have existing systems in place or you want to look at some new solutions. We discussed various scenarios under implementation and some of the considerations that you might want to think about. And finally, we'll cover some benefits and case studies. So with that, and then occasionally, just one point other to make, this is not a product demonstration. It is more about the principles and guidelines and so on for managing environmental assets, and particularly vegetation. Though I might make references to our product, which is called the Tree Asset Manager, more to kind of make the case that, hey, this thing is being done, it's being used, and as part of the case study. So with that, let's first look at what an environmental asset is. Again, there are a lot of, we know generally that yes, it's a system, and in terms of the definition, again, we don't want to belabor the point, but I generally categorize it as anything that is non-built, not built by people, and that includes everything, health, trees, habitat, land, and so on and so forth. So what are its key characteristics, and how does it translate into how we manage it? So first, they exist as complex systems. That complexity and the scale of the system can depend on a case-by-case situation. But the point is, if you want to manage it right, you need to take some systemic perspective. You cannot manage things in silo. I mean, you can, but it won't be as effective and efficient. They are constantly changing. So in order to deal with that, you need something that is adaptive, and adaptive in more sense than one because of the way nature changes. They have increasing value and liability over time, which is very different from built assets. Now, the value component is more relevant for urban forestry, but on the liability side also, I guess as trees grow, it grows with a greater risk. The other one that most people may not have kind of considered it, though intuitively you may know about it, you may feel it, is that nobody owns an environmental asset. People may own a lake, or they might have right to a land, but there are certain regulations, there are other stakeholders. There are always other stakeholders kind of involved in some way, either regulators or other entities or the consumers or what have you. The implication of that is that you need a system that enables this kind of meeting the different stakeholders' needs who might have a diverse set of interests, i.e. some kind of a smarter, a little bit more sophisticated collaborative approach. Then now when it comes to, when you look at a normal asset, you try and understand its performance, its characteristics. In the case of environmental assets, they are constantly, not only are they changing, but their performance within the same, what I call the same asset class. So if you have the same tree of the same species, it's going to be different, whether if they are separated even by, a mile or so. You cannot kind of make that claim about pipelines and power lines and all that stuff. And that relates to modeling, that and the next point about performance-based systems. They are very dependent on historical conditions, the droughts, for example, and initial conditions. So in a classic case we have run into outside of vegetation management is stormwater, green infrastructure applications, where the amount of rain that has fallen will determine the impact of the water that is retained. So how do you kind of model that? Okay, now you need something more sophisticated than benchmarks and metrics and other things. You need to kind of almost engineer a solution which is very site-specific and use-specific. So that changes the way how you kind of do the modeling. We'll get a little bit into it, but it's a totally separate topic. Another kind of interesting angle is lack of standards. There are no IEEE, ANSI, and all these other standards out there. Everything is different. So a one glove fits all kind of a solution is going to be totally inappropriate. Everything, whether it's for a small utility or a large utility or any application, it has to be kind of customized because nobody is going to no two companies are going to do the same thing. And the last, that they interact with built assets, and of course that will also change because of all the other things. And the scale and scope. The idea of scale is, let's say, large number, okay? And like our vegetation management, we are dealing with large numbers of things. So things that might work for a small number of things will start having problems when you start scaling up. And the second concept is scope. So let's take land. Land can be your backyard, it can be a street, it can be a city, it can be a park, it can be a watershed, it can be whatever. So, and again, if you think of environmental assets as a system, that systemic components, that scope can be changing different times. So now if you want to manage them, you're going to run into different scales and scopes within different parts of your region or different part of your network. And the system should be able to cope with that. So this kind of totally changes the way you want to approach the management of environmental assets as compared to built assets, and the details we'll get into. A couple of some kind of observations around it, and I've been part of the reason I founded EcoLayers was the recognition, and there's another long story behind it, the recognition that environmental systems were very inefficiently managed. This was many years ago, and all through right now, and you can look in your own life experiences, when it comes to managing environmental assets, whether it's a water, a 401 permit, or vegetation, they're inefficient, very inefficient, compared to the way businesses are managed today. If you look at how businesses are managed, they're phenomenal. And let's take our own example about utility, generation, transmission, distribution, phenomenally managed. And what is one of the most kind of high cost items is vegetation, i.e. an environmental asset. So this kind of carries over. Okay. Paul, can they hear me?
Yeah, sorry, Joe, go ahead.
Okay, fine. All right. Sorry about that. So they're very inefficient, and I was saying earlier that look at our utility operations. The generation, transmission, distribution are very tightly knit. They're managed as an integrated system. Vegetation is among the more kind of inefficient, and I'll explain what I mean by that in due course. Is part of an environmental asset. And we've done about, and I say this with some experience, a little bit of credibility, having done about 35, 40 projects covering a lot of different asset classes from water, land, and a lot of kinds of things. Having said all that, this is still a new space. Okay? So pardon me if there is something that I'm wrong on. I'm always willing to be challenged. And feel free to contact me or Paul, and we can discuss it further. So what does that mean now? In terms of what's happening today. There are two kind of class of systems that I'm seeing generally. One is manual systems, and I would add that electronic, and we'll talk a little bit in due course. And the other one is GIS and asset management systems. Now, going back to the earlier slide, manual systems, again, I don't want to belabor the point, but almost everything is in silos. And by silos, I mean there are data silos, process silos, people silos, organizational silos, and each thing is managed by its own self. So you definitely cannot scale, you cannot do a lot of things. And of course, it's expensive. Coming to the GIS and asset management systems, I use the terminology, the concept of their component technologies. And they're also kind of limiting. I would say that they have been used for vegetation management as an extension to built asset management. Classic case is asset management systems. But when you think about it in the larger picture, in terms of a systemic integrated management, as I mentioned earlier, they are component technologies. So if you look at how Oracle and SAP are set up, like business enterprise systems, they have a lot of functional components in there, from finance, accounting, HR, inventorying, sales, marketing, what have you. Accounting is just one component in there. Now imagine if you are going to use just accounting to do all the other stuff. Well, I mean, in the 60s, IBM first came out, they were doing that. They started with accounting and they started extending it to do other things. But very soon it choked. That's kind of what I suspect is the fundamental problem that people run into when using these traditional systems, asset management system. And if you look at a typical asset management system, they have a lot of breadth in the type of asset classes that they cover. But when it comes to the depth of analysis, the intelligent decision making, et cetera, they don't have the depth for each asset class, because each asset class behaves differently. And classic case is vegetation management. It behaves very differently from pipelines and poles and transmission lines and storm drains and so on and so forth. So given that these are component technologies, you're also forced into different silos. So the ability to do the systemic management is very difficult. I think this is where the kind of state of the art is today. There is a need to kind of rethink the stuff. So look at this slide, sit back and say that given the characteristics of environmental assets, what are we going to need? Okay, so this is what I kind of have come up with and I'm using to communicate some of these ideas. And the primary kind of driver behind that is any solution must fit the nature of the problem being solved. I tried to make the case earlier that what we had was not kind of fitting right there. This is the slide. I don't want to get into the details for each one of these. Some that I have covered, like adaptive integration, the scale and scope. The modularity I kind of include in there because given the large scale and scope of managing environmental assets, you cannot start with all of them at one time. You need to start slow and evolve over time. It depends on, again, your needs, interests, budgets, and all that stuff. So modularity is important because, the diverse content, you need a lot of different types of information which changes over time and space. And you've got to be able to kind of aggregate and integrate that content. The other is where, again, it's just my kind of observation here, that GIS systems are kind of designed, their DNA, their core essence, is designed to create and manage spatial content. I would suggest kind of take a shift away from that, and think of spatial content as just data. And so, for example, if you want to kind of view PDF forms, you don't need to be an expert, or you don't need systems that create those PDF forms. So, in a lot of our cases, you need, in our application for users, for vegetation management professionals, you don't need to be a GI expert. You don't need to be creating and managing all the content. You just want to be users of that content. So that changes the perspective about how you want to look at spatial data. The knowledge-based issue comes up again is because of the nature of environmental assets, as I explained earlier. Yeah, so you can have the information, but in order to make decisions, you need knowledge. Knowledge is something that is collected over a period of time. Now, when everything is changing, as we kind of discussed earlier, trying to create a knowledge base is important and a little bit challenging. But it is very critical in order to create smarter models and better decision frameworks. So I've included that. And then, of course, collaboration, we have mentioned cost. The open systems is a very practical thing and user-friendly, of course, otherwise nobody will use it. So then, these are the broad requirements that we have implemented, okay, in our system, and that's part of the case studies that will come. How does that translate into business? I didn't know how best to present it, so this is my best shot. It's a very strategic level. This is showing what is called the McKinsey 7S framework. I have a link at the bottom. You can check out the details. But the three hard, and this basically they are saying that there are three hard S's, which is the system, strategy, and structure, that determine and are critical for any business, any enterprise, any large project, or anything. And they depend on each other. So, strategy can drive systems drive strategies, which is our focus of interest. And I'm proposing here that the systems that we are using determine the strategy. So, for example, if you are using manual systems, in a manual thing, you're going to do things in a certain way. Same way, now, if you start redefining the problem, as we've been talking about, your strategies are also going to change. And that will also affect the kind of systems you're going to look for. So that becomes a very virtuous kind of a feedback loop, and ultimately will end up benefiting the business. How does, in terms of cost, okay, how does that translate? So we have, the typical method that we see is what I call the marginal cost reduction. We're all familiar with it. So over experience, you'll get better and smarter at doing something. However, I think what the real essence of progress in our business is structural improvement. And what I mean by that is shown in this graph as best as I could. Basically, you are at a particular cost curve. Let's say you're on manual here. You come down the cost curve. There are technological changes. You structurally change the curve. You're getting down the lower cost curve, and so on and so forth. Ideally, and this is happening in the rest of the world. Okay, look at technology. Look at all the new companies that have come up everywhere. It's been going on for 100 years. So nothing new about it. But the idea is you come down the steepest part of the slope curve, then come back again. Don't hang around at the bottom part of the curve. Keep coming down again and keep coming down. And to put it into the context of our world, I would propose that, it has been going on, whether we recognize it or not. There is a manual paper curve. I call it electronic. So you're kind of moving away from the pure paper world to electronic components. Asset management, GIS systems have come up. And the next paradigm, the next model curve I would propose would be kind of managing vegetation as environmental assets in the context of the topic for this webinar. How you kind of move from one to another, I guess that depends on specific instances, but the ones who are doing mostly manual or electronic work, moving to the newer approaches might be far more recommended, especially if the systems are affordable and economic and et cetera, But people who have a very deeply entrenched, institutionalized systems for asset management and GIS, particularly large organizations, these shifts are not easy. So there is I propose some recommendations for how you can make that shift seamlessly. When it comes to the implementation, again, the way I want to kind of, again, I mentioned earlier that these things show, the traditional asset management GIS system. So this is kind of the layout that you see typical. You look at any kind of vegetation management software that I've seen so far, and I'm open to be corrected. It follows this kind of a hierarchy, and there's a whole bunch of other boxes. Now, my kind of analogy, given all that we have talked about so tweaks, and sure, you're going to get a plane that can fly. So what I would propose is that kind of the plane solution, we need to think differently. So instead of having one of these component technologies as a platform, what we've done is, in our case, and there might be other ways of doing it, we have ended up creating a new platform, which is we're calling the Environmental Asset Management Platform. And notice that the asset management and GIS are kind of modules or components within this platform, which kind of takes into account, it kind of integrates coordinates, asset management, GIS, and all these other things. Again, it's a technical discussion. We don't want to get into that. But it's a fundamentally different way of even starting out on how you want to deal with this new way of managing. And all the stuff that I mentioned is handled here within this environmental asset management. And these are all components that are invoked. So if there is no need for spatial content, you don't invoke the GIS component. But license can still go on without having a GIS system, so to speak. So then, okay, and like I said, this kind of systems may work for built assets, but for environmental assets, you need something different. And this is how we have actually implemented it. And again, this is real. It's work. It's been done in, like I said, with many projects. And again, some of the stuff we already discussed. So again, no rocket science. Okay, this is very logical stuff. So first, you need different kinds of content. Okay, that's clear. Then you need to do the aggregation and management. I would add integration in there. Very basic stuff. All enterprise systems do that. And then you have users. The user has some different levels of collaboration. I would contend that when it comes to environmental asset management, you need a far more sophisticated collaborations and permissions environment than what is more commonly found in the systems, the traditional systems. And from this, you need to create all the vegetation management applications. However, these management applications, they require all these other functionalities like asset management and GIS and other things. So I call it the intelligence layer. And so that comes in as a final, the individual components that I showed earlier. So you got the content, you got this intelligence components of which you create the applications which interact with the users. Just a few words, the traditional asset management systems, at least the way we approach it, we actually took a very high-end, sophisticated asset management system, which we call it Mini Maximo, but it's been totally adapted for managing environmental assets. That shift is not easy. The models and analytics also we had to totally rethink how it can be done because of the situations that I explained earlier. The spatial content server, see, I'm not using the term GIS because we don't want to be in the, this is not a GIS project. This is using spatial content to solve business problems. And so kind of have a GIS server, and there's a lot of stuff, a lot of servers out there that you can use. Workflow management is critical that we all know, and user management. So this is our overall kind of system that has been set up. But now, not everybody can start off doing that. But, and so if you want to make a shift, I'm proposing two kind of alternatives for organizations that have an existing GIS and asset management platform. You kind of unchoke it by having a separate integrated middleware platform. We are looking and have done a few projects like this, where the enterprise, the environmental asset management comes out as a separate. It kind of brings the data from a lot of different sources. It can manage the changes, the adaptability, and other things by pooling the systems or integrating the systems in a way that their institutional processes are maintained. So, for example, regulatory requirements on service orders, failures, asset maintenance, all these things will be maintained within your legacy existing systems. But any of the intelligence and the other smartness that you need for vegetation might come out of this middleware. In terms of the transition and how this means, I would again suggest that, depends on how deeply entrenched the GIS asset management platforms are within the organization. Oftentimes, they are just using it for service orders. So very thin application for vegetation management, and the rest of the stuff is manual or Excel. In which case, I guess you're just better off starting fresh. There's no need to kind of do any, the integration will cost more. But again, organizations that are much more deeply entrenched systems, you might want to just think of a middleware thing. If you have existing manual systems, I guess, there's nothing, and I have seen a couple of utilities. They've done a terrific job. They recognize that there are some of these issues that they were groping with And we started out with kind of, if you have a manual system, you want to think differently, you first need to rethink your, I call it process re-engineering, because it's a new way of addressing the problem. And we kind of used, I kind of used the terminology of creative Excel and Google Sheets design. One or two things that I saw were kind of quite smart. It was a very well done job. So that at least is getting you a little bit off the manual stuff. You can bring a few things together, and it's a step in the right direction. The other thing is people have a lot of CAD drawings. Okay, if they have GIS, that's fine. But it's easy to convert CAD to GIS, and that can be a big help. And incrementally adopt integrated technologies incrementally, and smart sheets, and there's a bunch of tools out there. It won't get you all the way there, but at least it's getting you in the right side. And the only caveat and kind of a caution I would like to put here is that keep assessing the ROI, because what happens is you kind of get too kind of warped up into kind of improving the process that you have currently. And by the time you kind of squeeze more and more, you again end up choking the existing tools. Your expectations are more than what the systems can do. And then the cost becomes high and the ROI kind of gets hit. So that was kind of, we looked at the concepts, we looked at the implementation, and here we're going to look at some case studies. I want to present here two kind of examples. One is a company called Plant Growth Management Systems based out of Michigan. They are, one of their businesses is utility as a utility arborist. They are serving several utilities, electric co-ops and munis out in the Midwest. And they manage things, when I use the term environmental asset centric, so TGRs, herbicides, they look at trees. Okay, that's one. And the individual here is Mark Mann. Some of you might know him. Very deeply, seasoned and experienced in the world of TGRs and herbicides. I would say I've learned a lot from him, and whatever you hear about TGRs and herbicides, and we basically implemented that system for him. So I did not know anything about this until I learned from him about these things. The other one is Pedinalis Electric. Theirs is a kind of a different situation where they are starting out what I call the utility asset centric, meaning they don't have an inventory. They are doing traditional line clearance, and we are helping them collect inventories, but not individual trees, but along spans. And we are looking at just line as a utility. So it's kind of, you're looking at the feeder network and enabling them to achieve these goals of vegetation management, environmental asset management through that mechanism. And later on, they want to add all these other things. The point is eventually both will converge, even though they are starting out from different worlds. And as long as you want to kind of think the right way, and you're fine doing that. So this was the setup for the PC. There is a link here on an article that recently came out in the D&D world. You can look into it for more details, but they want to kind of move from a reactive strategy and build a mix of routine, proactive, predictive strategies. This is part of what I call setting up a system, the virtuous cycle, where you kind of start out with something, build on it, but what you build, you turn it into a knowledge base. That's kind of the approach we are taking. We started out with, the circuit miles and spans is what we are helping them with assessments. And this is kind of where we are at the moment. And, it's also a case where strategy and systems interact. So learning more about what can be done influences the strategy. So we kind of, go through a few iterations in the requirements and the scope of the functionality and so on and so forth. So that has happened here. You can kind of see it, and it happens in a lot of different projects. Coming to the PGMS system, theirs is a different scenario, where they are looking at individual trees, but in the context of feeders. Again, these guys are very particular about their utility management programs, and kind of want to look at reclosers and all the particular details and plan very meticulously what they want to do. So we have integrated the utility assets and the vegetation assets, which actually is an important point, that you cannot just look at vegetation assets in isolation when it comes to utility vegetation management. You also need to bring in the built assets. Now, being able to integrate built assets with environmental assets is another ballgame. Okay? And they're bringing together different feature classes, different types of assets, especially where they're going to interact, is a challenge. So that's what this kind of project is. And just for the side, for comparison on the right, you'll see an example of a PEC system where there are no trees. They They are just feeder networks, and they are colored, based on the work status. We are showing different things there. So the idea, so for, let's say for the piece, whether it's PEC or PGMS, let's talk in generality. Okay, both of I'm going to kind of go through the next few slides with particular kind of benefits. The fundamental one we talked about, structural and continuous improvement, the charts that I showed you. Now look at it, the kind of primary benefits here. Okay, we know from kind of experience and research and all that stuff that a small number of trees are actually causing failure. But again, it's my observation. So again, open to any corrections. But when it comes to the maintenance, we treat all trees as equal. So let's say pick a number, 3%, 5% of the trees are actually causing failure. We are treating all 100% of the trees as same. They're equally likely to cause failure. Again, I'm being too generalized. I know there are ways of kind of zeroing that on that. But the idea is that there is a low ROI. Now imagine if you had perfect vision. Okay, we are not there. Okay, but we imagine you had perfect vision and you can identify the precise 3 or 5% of the trees. What would that mean? What will that mean to some of your existing regulatory issues that you have to spend a lot of money on by treating all trees equal? That is fundamentally the kind of direction I want to go. That's how we have designed the system, and I think there are very clear pathways to that. And how do you kind of go about it? Okay, there are two kind of directions. One is you get better data, knowledge with all the stuff we talk about to keep identifying, to narrow the scope of trees that are dangerous. So initially, let's say all 100% of the trees are equally likely. If you bring in better analysis, better information, better processes, and all that other stuff, and you can now look at 80%, then become 75%. Whatever it is, you reduce someone. You're never going to reach the 3 to 5%, but having a high confidence level that some X% of the trees are more likely, is going to result in some very major reduction in cost and improvement in performance and all these other things. And the other part of it is delay the trees. Again, so that's TGRs and herbicides. And again, you guys are the bigger experts on this, so we don't want to get in. I won't talk much about it. And this is the diagram that I kind of wanted to show what I mean by this virtuous cycle, that using the knowledge base and so on. If you have a knowledge base that includes your environmental and built assets, and I will include in the built assets the condition of your existing utility assets. An old conductor, in my opinion, will behave differently from a brand new conductor in terms of its ability to withstand failure. Okay, so I haven't kind of seen that integration take place, and that's in the direction that we are going and we want to go. But once you have that, you have the current state today, what is happening, based on you apply your modeling, analytics, whatever, and you prioritize. The issue is not, well, it is important to have efficient work order management and work management systems, i.e. the pending jobs, complete jobs, approved jobs, okay, the job management part. Yes, and scheduling and vehicles and fleet management. Yes, that's important. But more important, I propose, is prioritizing and what, when, why, what you want to do. So the work order management is a linear, systematic process. Yes, everybody can do that. But the more challenging part is the front-end piece to determine what needs to be done when. And that's what I use the term of assess, prioritize, integrate, and intelligent scheduling. So from there, you do the maintenance and monitoring activities. So it's not just maintenance, it's also monitoring, which can be manual field, or it can be UAVs. Actually, UAVs can have a very profound impact in this. And so then you get a new state, which becomes part of this. So when you want to do the planning for the next cycle, you have an updated system that's ready to go, and you can keep moving on this cycle of continuous improvement. That's the idea there. When it comes to the tree growth regulators, I guess the industry knows that there are benefits on it. Some have claimed that there are no benefits, but again, I go back to Mark Mann, who says that they are not being fundamental issues, they are not being applied properly. And PGMS is, like I said, very particular. They have been 25 years, developing TGR techniques and have done some very successful work. However, they were dealing with smaller utilities. First, they were doing manual, then they came up with an Excel approach. But again, it was getting very cumbersome and painful to plan and do it right. Okay, whatever that means a lot of things, but doing it right was becoming very challenging and very painful. Until we met serendipitously somehow, and it was like, okay, let's look into using this environmental asset approach to accomplishing what they are doing. And so we did implement the CGR module for them. I've shown some of the key capabilities here. So you can have this presentation and look at the details. Happy to discuss it later. But it's a complete package that addresses a lot of the issues that they were having in terms of identifying the trees for the next cycle and what quantity. There's about 13, 14 variables that go into this modeling, or call it analytics or whatever. And some of the benefits that they have experienced, this is within a year, year and a half of use, phenomenally, I think, interesting numbers. They increased the daily number of trees by 55%. They were on that manual electronic curve, so I guess that, and I mentioned earlier that they'll have utilities using those components by doing it in a smarter, different way, can see phenomenal improvements in planning and management, and basically people time by 75%. They have, again, the system's not being used for long enough, okay? But the techniques have been beneficial in reducing UVM budgets by 35% over 2 cycles with TGRs alone. And when you start including mechanical TGRs, herbicides, you can achieve your UVM cost reductions by 75%. Now the challenge is this: you can use Excel and all these other things when the scale is small. One of their biggest kind of obstacle was, and even that, for the scale they're dealing with, they were choking. Now, you want to start doing anything big, it is just impossible to use these things, and even your asset management GIS systems, to really get to where you want to go, which is where I think there's been a good fit between what we've been doing and what their needs were for the tree growth regulators. The same thing with herbicides. Again, there is a whole body of work out there, and a lot of people might have different views. I'm going with what we had to do for PGMS, and the problem was very similar. I've seen situations where people, they are herbiciding entire right-of-ways, miles and miles, thousands of miles. These guys are taking a much more focused approach where they are identifying specific areas. What is right, what is wrong, I leave it to you experts. But the way it's been done is, we help them identify specific areas. It becomes kind of an environmental asset entity, which becomes part of the inventory. And then we have this complete cycle. One of the most important things I've learned is the proper coordination between the mowing days, the quantities, and the time, and all that stuff is extremely critical. Most kind of herbicide programs fail because that is not being taken into account. And just similar to TGRs, we kind of have applied similar approaches here, and reduce the need by third or fourth cycle using kind of techniques. But again, when it comes to scale and scope, large number of areas in different kinds of situations, the systems will kind of fail. And that's where we are trying to help them do their stuff better. The last case study I want to bring up here is use of digital data platforms. This is kind of a general terminology I use for UAVs. It can be LiDAR, it can be hyperspectral, what have you. So I believe, okay, given all my kind of experience about different areas, it's got some very, very fundamental transformative capabilities. And I have some idea about how is it being used today, particularly around transmission lines. Distribution is not quite there, but it's not being fully the true potential is not being realized. I kind of, again, attribute the reason is because of the tools and the kind of perspective. It might be okay for FACO, 003 compliance and other things, but again, imagine if you want to go and identify those, or move towards the direction of identifying 3 to 5%, okay, could be 20%, 30%. You need kind of a different way of massaging that data, sucking that data into the system. And that's where currently almost everything that I've seen is that this digital data, it's got some pretty rich, sensors are getting better. I mean, it's just like mind-boggling to me what you can do with that. Today they are delivering the GIS platform. You might have some very sophisticated visualization, fine. And I have some other views about what about this visualization stuff. But at the end of the day, you are managing another silo, which is not integrated with the rest of the UVM programs. And in some cases, I've heard that identifying that there are a lot more danger trees, it kind of becomes budget busters, and some organizations probably don't want to know there are so many trees out there. So anyway, these are some of the issues, and what I propose is that if UAV, if you remember one of my implementation diagrams where I had UAVs as one of the inputs, they become part of a more comprehensive, systemic, integrated, collaborative environmental asset management system. You can accelerate your process. Okay, depending on the cost and economics of the digital data, it will take time. But I think the time is right to start learning about it to those who can afford it and who can have an interest. But the benefits I see are improved accuracy and confidence of digital data that we know. But now you can use that data along with existing data, including utility assets, to start improving your intelligence and making smarter decisions. And use the word autonomous inventory. It's not never going to be totally autonomous, but you can do stuff more digitally. And it might look like a little bit pie in the sky, like right now. But let me give you an analogy of where kind of the rest of the many other industries have moved. The classic example is marketing, where initially they had very broad, loosely defined segments. When Kotler first came out with it 60, 70 years ago. 34 years ago, I forget now, maybe 50 years ago. But today they can target, if you read about all what these political consultants do or even marketing, they can target things by individual streets, by individual families, individual behavior. What is that? There is a lot of overlays of data, a lot of analytics, and a lot of stuff that goes into it to be able to target things. So yes, I don't think the vegetation management industry, from again what I have seen, is ready for it in the sense they are doing it, but I think that the capabilities are there, the information is there. What it needs is the proper systems for creating this knowledge base and making it usable along with the analytical capabilities and all these other things. But this can substantially, UAV can have a substantial impact when it's integrated into a more comprehensive asset management system. So, kind of nearing the end now, what does that mean? Okay, so if you have an environmental asset management system, I gave an analogy earlier about Oracle and so on. What is one of their distinguishing characteristics? They don't go around creating custom solutions for every customer. They have a platform. They go understand needs, go through the discovery process, and marginally or incrementally customize those systems to provide very unique solutions across a wide range of industries, from tires to aeroplanes to what have you, all in the industries. The underlying platform is the same. It's interpreted. Now, they have standards. The tax laws are well defined. International rules all those things are there. We have a slightly different class of problems. But the point is, at least the approach we've taken is enabling that, creating an environmental asset management which can meet a broad range of environmental vegetation management needs, from electric utilities to urban forestry and other environmental programs that are part of the problem. And in some kind of situations where these things become very relevant is, let's say, municipal utilities, where you have to manage utility trees and street trees at the same time. Now, I would propose that, we having some smart ways of, and the goals are different. So utilities, you want to chop trees, street trees, you want to grow trees. How do you people are doing it today, but is there a smarter way of doing it? I know some people are looking into it very seriously. But again, we have one project right now which we are doing precisely that, and maybe in the future we can talk more about it. But I didn't include it into the case studies because of that reason. And I think so these things exist, they are doable, and I think it's worth your consideration to looking into environmental asset management as a new way of doing things. And with that, I think I want to conclude my presentation.
Very good. Thanks, Joe. Okay. All right, very good. So, yeah, right on time. So we have 10 minutes for Q&A. What I'm going to do is unmute everybody on the line. And if you have a question for Joe, please state your name, your organization, and then what your question is.
Conference unmuted.
All right, so anybody got a question? Anyone? Floor is open if anybody has a question for Joe at this time.
Well, Joe, I think that was an excellent presentation, and you gave us an awful lot of information there. So I think people are trying trying to digest it. I know I am. There's a lot of concepts and a lot of stuff to think about in that for sure, but really good information.
Okay. Well, I appreciate the time everybody's taken.
Joe?
Thank you again. Yeah.
This is James Urbanowski from NB Power calling from Fredericton, New Brunswick, Canada.
Hi.
If you could go back a couple of slides.
Okay.
Is it possible to go back on a slide?
Sure. Sure. Which one?
Just go ahead a little bit, kind of towards your end. Well, now you've gone all the way back to the beginning. I apologize. Go closer to the end.
What was the topic?
Well, I'm ultimately going to get you to try and summarize, because how... Keep going. Are you going... keep going to the end. Keep going. Okay, one more. One more. Well, let me ask it this way. Just leave that slide there.
Yeah.
We're most of us, I think, listening are utility vegetation management teams or organizations. And most of what you're talking about, I kind of related to, and we're at the middle or the end. We have asset management systems. We have a well-integrated GIS system, and we are actively for the last 3 years looking at LiDAR as a data and inventory source and helping us understand the current state of our system based on every time you bring in LiDAR data. Analytics is something new that we're interested in to make better decisions on understanding what the asset is at any one time and bringing in other data sources to understand what is a priority circuit, what are our customer needs, what are our asset age classes. So I think I understand most of where you were coming from, but I'm trying to understand why you're focusing on treating this as an environmental asset. What is your whole concept here? Why, if I've got most of the pieces, why are you leading me to think of this now from an environmental asset point of view instead of maybe where I'm at in my current state of using GIS and looking at all of my assets?
I don't know your complete system, so you might be doing this. You might be doing this. So my key point on this is this one here. Where is it? Let me just go back. This one here. And these requirements are driven from this list here. Okay. So if you are doing this already, then you are there.
Well, we're not there, but we're learning how to.
Okay, fine, but that's my point. I'm not being critical of GIS asset management systems and even LiDAR. My only point was that they need to be kind of brought together into a framework like meeting these kind of requirements. That's all.
Okay. And
that's all. And if you look at, sorry.
And by creating this new title called environmental asset as opposed to hard asset. Everyone in our organization always thought of poles and wires and transformers and generation facilities and et cetera. Those are the hard assets, and they manage those hard built assets. And vegetation, it's taken me 5 or 10 years to create that thought that vegetation was also an asset, but it's a different type of asset. Yes, it is an environmental asset because it includes other plant species and streams and people's interaction with those environmental assets. So it's been a challenge, but we're there. We're at least recognizing that it's more complex than.
That's great. That's great. Great. No, that's all. That's what I'm trying to say. That and I mentioned earlier, if you have all the pieces there, you're going in the right direction. I mentioned about utilities that are using Excel spreadsheets. But they're trying to kind of move in some direction like the slide that I'm trying to show here, which is based on the fundamental characteristics of environmental assets. which is vegetation. Okay, so vegetation, basically I'm saying that if you start thinking of vegetation not in the same league as power lines and the built assets, then you start thinking of additional requirements and issues that need to be brought in, and this is the list. This is a short summary of that. And there are a number of ways of going about doing it. So you have the different systems in place. Some might be doing it in some other ways, and we have just put together a separate comprehensive platform that enables that. So it is much cheaper, so you don't have to buy different systems and integrate them and so on and so forth.
Okay. So your presentation was attempting to show us a way of integrating these different systems and your
and requirements, yeah, and the requirements that need to go into it.
And the suggestion that by doing this, we can create a different or a less expensive strategy or...
That's right.
All right. Well, I found it a challenge. There was a lot there, but thank you. My question is ended.
Okay, anyone else on the line have a question for Joe? No, we'll give it one more chance. Anyone else? Anyone else who's on the line? Now's your opportunity to ask Joe a question.
I'm assuming this presentation will be available through CIADI afterward.
Yeah, Jim, I've recorded it here, and I'm going to post it on the portal later today.
Great, thanks.
All right, Gwen. Joe, you've given your contact details, and I'll make sure that they're also in the presentation that I'm uploading. Gwen, do you have any parting comments?
No, just thank you very much, Joe. It was a great presentation, really, really nice visuals. As Jim said, yeah, you've given us a lot to think about. I think people are just sort of digesting the material.
Yeah, Jim, I think Jim, you were the one asking questions. I hope I got your name right. Well, if you have any, if you want to have a separate offline discussion about this, I'll be happy to talk to you.
Sure, thank you.
Around what your existing systems are in place.
Yep, thank you.
But with that, I'd like to thank you once again, Joe, very much. And yeah.
Very good.
Thank you, everyone.
All right, thanks, Joe. Talk to you again.
Thanks. Thanks. Bye.
Bye-bye.